Good afternoon. We're looking here at a graph movement part 3 video. We've presented 2 already in the past, and I'm presenting a third one only because I want you to understand the graphs of the exponential and the natural log functions with regards to movement. And in terms of movement and graph representation, we're always looking at something like this: x plus and minus h plus and minus k. The only thing I'm doing is removing this a with regards to the function because we've never looked at stretching yet. Or we can have a plus or minus which can indicate some sort of a reflection. But this is what we've looked at: horizontal right and left translation, up and down translation, and a vertex here always at h comma k, a plus and a minus before it to represent whether a graph is pointing upwards or whether it's reflected downwards. But we are looking here at everything with regards to e to the x. I want to use letters only like we did in the previous 2 videos on this same subject, and understand that this is just general practice only, so you can understand how translations up and down, right and left fit into your equation forms. Our basic equation form is e to the x, and in each instance I've shown you a dot which represents our focal point for that graph, and we can use that dot to represent what movement has occurred. And we are only going to be looking at equation forms here and nothing more than that. So let's look at this. We have an e to the x. This is what we start with: if graph of an exponential function, and here's our dot, and we see in the next the movement, the dot has moved slightly to the right. We know rightward movement is really represented by an x minus h in terms of horizontal translation. So how can you represent this movement to the right with regards to your original equation? We're not going to bother writing f of x before each equation just for neatness sake, but our equation here will become e into the power of x minus h. You see, this x minus h will represent that we moved horizontally towards the right. Now when we focus on this graph, we see that that dot with regards to the graph has shifted downwards, and we have to represent an equation form for that, and we can do so easily by saying we have a downward movement, e parentheses exponent x minus h but minus k. This minus k represents we shifted down by k units, and you can see everything is coming into this form. When we look at this and we go over here, we see that we reflected everything across in an up and down direction right here. If this was my original line over here, we reflected across that, and we can represent that in terms of this minus e exponent x minus h minus k. This minus here is very well reminiscent of this, coming before your equation to represent an up and down reflection. A positive means going upwards like it was, and a minus means you reflected downwards. So these are your relevant equations here. E to the x represents your basic, e exponent x minus h to represent the rightward, the minus k representing a downward movement, and then here a minus before everything to represent a reflection across your horizontal line of axis. Our second and last question will make us get familiar with this natural log function. You should be familiar with the exponential and natural log because as precalculus students or students in your advanced high school math class, these are functions you should know in terms of their movements, the graph movements. If this represents your basic function here of the natural log, and this right here is our focal point, and I represented how the focal point has shifted, we can then decipher the movement. Here is our starting point, and then we notice we moved towards the left, and we can very well represent that as natural log x plus h. Remember, x plus h will indicate a leftward movement, x minus h rightward movement. Why would this be the case? Because you're doing x minus minus h. In all instances, the formula is always x minus h. Then this is being altered by either a leftward movement, it becomes a positive, or it stays the same with the rightward movement, in which case you're looking at x minus plus h, right? You're shifting to the right by h units. Here you're shifting to the left by h units. Anyhow, the equation form is right here, as you're seeing next to the graph, natural log x plus h. When we look over here, we're seeing this curve has now shifted upwards, and you know that very well would be natural log x plus h but plus k. With regards to these plus and minus k, up is always plus k, down is minus k. It's the x plus h and x minus h where you're required to think a little backwards or opposite to what you think. When we're looking at this and coming over here, we're seeing that there is some sort of up and down reflection going on across this horizontal imaginary line of axis, and that would be very reminiscent of this. You're bringing a minus at the very beginning of your function, and you still have everything else which stays the same. and that would be the answer right there. Natural log x, my starting point. I moved to the left, x plus h. I moved up, x plus h, parentheses closed, and then plus k. Then I reflected across a horizontal line of x's, and that's a minus right here. Everything else stayed the same. And with that, you can see how the natural log and the exponential graph movements have occurred. Keep all of this in your mind. Thank you for watching. Have a nice day.